So let's start with talking about multiplying fractions. In class, we've been talking about finding these contexts, and we just even said in the last one, right? We wanted 1/2 of 1/6, and that's how we got 1/12. So we want to think about, well, how do we show that? And maybe we want to start there, right? 1/2 and 1/6. So you can type in, right? It says type in any fractions, and now it's going to say go. So what do you think is going to happen here? We see half of a rectangle. This is, again, the area model. We're looking at the space inside of this rectangle. And then, but now we see this as 1/6 of the rectangle. What's going to happen when we do go? And if we think about this idea of 1/2 of 1/6, what do we want to do to this red piece? We want to cut it, right? Cut it in half. And so now we see when we hit go, they overlap. We are now showing either half of 1/6, or you can even think about it as 1/6, right here, 1/6 of this whole half, where we cut this half into 6 equal pieces and we want one of them. Or you can think about, right, we cut the 1/6 into 2 equal pieces and we only wanted one of them. So we can reset, and maybe we want to think about 1/2 of maybe 5/6, right? What's going to happen here? What do you think is going to happen? And think about how then this is going to help to develop that algorithm, right? You multiply the numerators, multiply the denominators. How do we see that happening here? If we hit go, right, they're going to go mash together. And here we can see, oops, sorry, it was one. I didn't mean to write 1/3, but same idea, right? 1/3 of 5/6. How many pieces do we have overlapping? We have 1, 2, 3, 4, 5. And out of how many is the total, right? So this is our 5 out of 15. 18. Right? A 3, and again, a 3 by 6 array. And this is, right, 1 times 5, 3 times 6, because we have 1/3 of 5/6. And what if it was 2/3? Yeah, we'd have this 1, 2, 3, 4, 5. And so we'd have 2/3 times 5/6. So it would be 10/18. And you can simplify that. But again, this is how we can help, right? The models, the visual representations help to show where this comes from, right? Multiplied across the numerators, multiply across the denominators. So I want you, the next slide is going to have you playing. You can play with this, see what other kind of patterns you see, try other different fractions, and see if you can see and how you can see this standard algorithm for multiplying fractions.